Is this one? Oh, great. And so now it gives me great pleasure to ask Dr. Jack Martin, Professor, Chair at the Department of Molecular, Cellular, and Biomedical Science at the CUNY School of Medicine. Kathleen worked with Jack during her postdoc training and beyond from 2002 to 2007, and together they published a series of seminal studies that still serve as foundational knowledge and inspiration for many of us who work in the field of CP. So I do just want to read the prompt really quick. We said, Kathleen, the prompt: if this mentor were a scientific instrument, what would they be and why? Kathleen's response was, Jack would be Neurolucida, a platform for precise track tracing and histological measures. This is because Jack trains his folks to have high standards in science, and he's great at solidifying connections to help his trainees succeed. So,
wow. Neurolucida. I was afraid maybe a scalpel. Okay, well, so this is sort of, I guess, the second transition from, from Rice and Houston to Kansas, but now from Kansas to New York, and from kittens to kids. And so Kathleen joined the lab in the early to mid 2000s, and we were in the Department of Neuroscience at the time, and I was very, very fortunate to have gone to a party at SFN, Society for Neuroscience, in San Diego, where I sat next to Dao-Fen Chen, who had been at the University of Kansas before he became a program officer at the NIH. And I sat next to him, and we were just chatting, and he mentioned that he knew of somebody that was looking for a postdoctoral fellowship. So that was really made my day. So not too much later, I guess I emailed you, and then before I knew it, I was meeting you at LaGuardia Airport to give a talk. And to reinforce something that Randy just said, the talk was really extraordinary. I mean, it was so clear, and I mean, it really kind of made a lot of people very pleasantly surprised. And I guess people didn't think of you having a disability in a sense, because there were no limitations. I mean, it just it was amazing. So so soon after Kathleen arrived in the lab, she applied for an NRSA fellowship, postdoctoral fellowship, and which was successful, and that really charted her initial path in studying activity-dependent postnatal development of corticospinal tract in cats. And we started this with the eye of trying to develop a model for hemiplegic cerebral palsy that was really based on circuit changes and connectivity. And so together we did some further development of an inactivation kind of approach to turning off neuronal activity in motor cortex. It was before the days of dreads and fancy technology, so we just developed infusions. And and here is like the first no limitation of setting up these. Remember those miserable mini pumps that we used to have to put together and would get covered with crazy glue, and they were tough, but you plugged on and got a lot of good inactivations from that. And not to get into the science very much, but and what we were looking at there is, you probably know that the corticospinal system is a kind of a cross projection system, and in maturity, but in the young kittens, it's very strongly bilateral. And so Kathleen found that if you inactivated one hemisphere, that inactivated side kind of becomes anatomically impaired. Okay, I'll come back to the function. And the other side develops a very abnormal pattern, a pattern of bilateral connections. And so we thought that we had something there where we had, on the one hand, a hemiplegic side, and the other hemisphere could support mirror movements. which come up in hemiplegic CP in some cases. So it really set the stage for a new kind of model in this area. And so say again and again, I think it helped sort of keep your eye on how to focus on human studies with the kids. So that was our first publication, and then in order to look at functional changes, we developed a collaboration with Trevor Drew at the University of Montreal, and so the animals were prepared in New York, and it was my job to drive them up to Montreal, across the border. We thought it was probably more prudent for me to do that than for you to struggle at the border, and that's when the border was nice. And another postdoc in the lab, around Salini, who was trained by Andy Gordon, is like her first name indicates, she's Iranian, so we don't want her at the border. So it was a funny kind of project, schlepping up to Montreal with the kittens, and Trevor would test them, and we found that indeed the affected side were not able to walk over obstacles, and they were not able to do good manipulation. So we were on the right track, I think, in terms of developing this kind of interesting model. So it went on, and we conducted a number of other procedures and studies. And as the NRSA was sort of winding down, Kathleen and I were kind of talking about what's the next step, right? And that next step, as you know, is to transition to work with kids with cerebral palsy. And so she applied for a K award, and that started out as cats, and the cat studies petered out with time. And in parallel, she worked with Andy and Holly Lisenby, who was at, and I guess she had left PI. She was still there, yeah. And so then the human side built up. So it was a nice transition. And in that study, really, it was designed around kind of like a human study where these hemiplegic kittens, older kittens, would be put into three different groups: those that have a constraint, like constraint-induced therapy, so force them to use their impaired arm, constraint plus training right after the early critical period that Kathleen's earlier study really defined, and then constraint plus training during a later critical period. And what was really cool about that study is, like, for the kind of one of the first times, we took into account, looked at development of interneurons in the spinal cord and how those change in this kind of hemiplegic model. And one of the groups, the early trained constrained group, regained function, the motor maps came back, and importantly, the spinal cord premotor interneurons came back as well. So it was really very mechanistic and insightful, and hopefully it'll inform future approaches. So, and then do I have another? Yeah. So, and then Iran Salini and Kathleen collaborated on a stimulation study, which is kind of the opposite of an activation, and that did two things. It kind of tested the hypotheses that she developed in the earlier studies, and also brought to bear a kind of stimulation-based therapy that we're basically doing and been doing for a long time. So it was a super productive period. There were 4 first author publications, and in total, I think there are 13. And just like Randy said in Kansas, she was wanted to get involved in everything, and was so involved and so effective in design of experiments and in writing. And I don't think I've ever had anybody that could really contribute that well to the writing. It was really super. So I guess to close, the cat studies, I think, did shape the human studies, put them on a kind of a trajectory. And I should also say that those studies really defined how the rest of us in the lab went on with the spinal cord injury work, and it's really remarkable how it spread like a good infection in terms of all kinds of ideas that kind of have at their root the early studies with Kathleen. And for sure, those four first author papers and the whole boatload of other collaborations helped me move the renewal process very effectively. So it's been a gift to have been working with you. It's been a real gift to follow you with your work and the human side of the business. And even though I wasn't directly involved, it's been super inspiring to see that happen. And and it's not just the science. I mean, when you look at least in my lab, the kind of nurturing that happened all of those years in terms of, there was a lot of folks that you touched that are, have been in this room and moved on. And so great science and great mentoring. It's a win-win. So thank you so much. I'll miss it. Thank you. Okay.